Good day, Sir Geldof, and good day, everyone. Our group for today, the Peru, will going to present the dataset that we have selected, which is entitled Exploratory Analysis of E-commerce Customer Behavior and Purchase Patterns Using a Synthetic Dataset.
Through the analysis of data generated from customer interactions, businesses gain valuable insights into purchasing patterns. This involves the use of large datasets to conduct thorough analysis, such as segmenting customers, predicting future buying behaviors, and exploring purchasing trends, all while ensuring customer privacy is not compromised. Research questions. First, which product categories have the highest churn rates for each age group? For this one, we use classification. Second, does payment method have a significant effect on returns in e-commerce? For this one, we used association. Lastly, how the preferred payment methods vary between customers with multiple purchases and those with single purchases. For the last one, we used clustering. Terminology. Exploratory data analysis, or EDA, is our first step in making sense of datasets. Through visual methods like histograms, box plots, scatter plots, and bar charts, EDA allows us to see the bigger picture. Moving on, we have synthetic datasets. Imagine creating a clone of real-world data. That's what synthetic datasets are. They're crafted using algorithms to mirror the real data structure and behavior. The chi-square analysis is a statistical tool which is a go-to for examining relationships between categorical variables. Think of it as a detective tool that answers if two variables are related or just coincidentally appear to be. The retail strategy implication involves using insights from retail data analysis to inform decision making and enhance business performance in retail. It focuses on practical actions derived from data to improve efficiency and competitiveness. Association mining rule or association analysis is a technique in data mining for finding patterns and relationships in large datasets, particularly useful in analyzing transactional data. Feature importance analysis in machine learning assesses how different features influence the prediction of a target variable.
Now, for the next part, we have the data understanding. We have the data sources from our dataset, which consists of the following column names, which is the customer ID, a unique identifier for each customer, and a customer name, that is the name of the customer, and the age and the gender, which are the demographics of the customer, as well as the purchase date on which the customer has made purchases of the product, and the product category, which purchase product that has fall onto, and product price, which is the price of the purchased product. And to be continued, we also have the quantity, which was how many is the product has been purchased to show that the price. Then we have the total purchase amount, which is the number of the amount spent by the customer for each transaction, and the payment method, which was the customer selection of which payment methods is going to be convenient to him or her. Then returns, which is the customer, if the customer has returned any of the product from the order, and churn, which is the binary column, to indicate whether the customer has churned or not. Here we have the following column names from our dataset, and we also have the following data type, the appropriate data type. For the categorical data, this would typically represent as objects or strings in the dataset. Additionally, for the numerical data, this is usually represented as the integers or floats of the data. And for binary categorical data, this may be represented as integers like 0 or 1, or as strings as yes or no. For 0 or 1, we have the true or false. And last but not least, we have the temporal data, which is typically represented as a date-time objects or strings in a specific format. Next one, for data analysis method, we utilize the Google Colab. So Google Colab, or the Google Collaboratory, is an open source platform or cloud-based Jupyter Notebook environment that is provided by the Google, which allows that users to write and execute Python code in a browser with no setup required. So aside from that, we also use the Pandas, which is a powerful and prominent Python library for data manipulation and analysis.
Now for the data preparation, basically know what we have in mind, what data we have, what we need to know. We have to clean our data. So first is to identify the missing values of our data. So when opening the raw data, we found that there are null values on the return types. So basically what we did was handle the missing values, which made the return types to be converted to 0, assuming that they haven't been returned in order for accurate measurement for our model. Next is to check for duplicates. We found that the age and the customer date age columns have the same values. So basically we remove the age values for our data. Next is to correct data types, which are integers and objects, which I will discuss in the next slide. And for the outliers, the data did not really have any outliers that could otherwise change our model's accuracy, so we didn't do much for the outliers. So next slide, please. So this is the raw data summary of our preparation. As you can see, here are the raw data data types which are included in the picture. So for integers or the numerical, we got customer ID, product price, quantity, total purchase amount, customer age, and churn. For objects with names, we got purchase date, product category, payment methods, customer name, and gender. And we also got returns, which is flow type, which is 1 and 0. And finally, this is the result of our cleared data, the final data to be used for our modeling. The data types that are left are customer ID, quantity, customer age, churn, total purchase amount, returns, and objects with names are purchase date, product, category, and payment method.
Proceeding to our data modeling, there are 3 questions that our group created. And these questions are going to be answered by using multiple data mining tools and techniques and evaluate all of the data that we have analyzed. The first question that we want to answer is, does payment have a significant effect on returns in e-commerce? And by using the chosen data mining technique called association rule mining, we can identify if there is a significant effect on the payment method versus the amount of returns. The data mining technique will be much more impactful in analyzing this data set because it can help us discover relationships between variables in a data set. So in this code snippet, the categorical columns, product category, and payment method into one hot encoded format. This creates separate binary columns for each unique category within those features. The association rules related to returns are visualized using a scatter plot. Each point on the plot represents an association rule with its position indicating the support and confidence values of the rule. This visualization helps us to understand the strength and significance of the associations between variables in the dataset. And this bar graph provides us a visual representation of the number of returns associated with each payment in the e-commerce dataset. It helps us to quickly understand which payment methods are more commonly associated with returns, providing insights that would inform decision-making in e-commerce businesses, such as identifying potential issues with specific payment methods or areas for improvement in the purchasing processes.
For this modeling technique, this model covers the second business question regarding how preferred payment methods vary between customers with multiple purchases, and those with single purchases. The chi-square test of independence is chosen as the best technique to analyze how preferred payment methods vary between customers with single purchases and those with multiple purchases in e-commerce customer data behavior analysis. For analyzing association between 2 categorical values, this statistical tests whether there is a significant dependency between preferred payment method and customer behavior, providing insights into how payment preference differ based on a customer purchase patterns. By conducting these tests, we can determine if there is a meaningful relationship between payment methods and customer behavior, guiding strategic decisions related to payment options and customer segmentation in e-commerce settings. This visualization of relationship between customer purchase behavior types, it begins by adding 2 new columns to the data frame: purchase count, which tallies the number of purchases made by each customer, and the purchase type, which categorizes customers as single or multiple based on their purchase count. It then creates a contingency table that counts the occurrences of each combination of purchase types and payment methods. It conducts the chi-square test of independence to assess if there's significant association between these variables using a significance level of 0.05. Finally, it visualizes the payment methods across different purchase type, aiding in understanding association between purchase behavior and payment preferences. We conducted a feature importance analysis using logistic regression based on the selected feature payment, identified through the chi-square test of independence. After encoding the categorical variable payment method using one-hot encoding and splitting the data into training and testing sets, we trained a logistic regression model to predict purchase type. We then extracted the coefficients from the trained model to assess the importance of payment method in predicting purchase type. The resulting feature importance analysis visualized through a bar chart provided insight into a contribution of payment method to the model's predictive power regarding customer purchase behavior, highlighting its significance as a predictor of purchase type.
So for the third question of which product categories have the highest return rates for each age group, we specifically focus on predicting counts of returns for different product categories across various age. We chose gradient boosting because it can handle uneven data, capture complex connections, and outperform other classification algorithms in terms of predicted accuracy. So given the job of estimating product returns based on features, we used gradient boosting for classification. So to address the class imbalance in our dataset, we used methods such as SMOTE, SMOTE, and random oversampling. So despite evaluating several algorithms such as random forest and logistic regression, gradient boosting continuously surpassed them in terms of accuracy and flexibility. So it earns our top pick for modeling. And while the model achieved respectable accuracy, it's essential to consider other metrics, especially in the presence of imbalanced class. The confusion matrix provided, as shown on the PowerPoint, is a detailed breakdown of the model's classification performance, highlighting its strengths and areas for improvement. So the confusion matrix provides a visual summary of our model's classification performance, wherein each row represents the actual class, while each column represents the predicted class. So the top left square, highlighted in dark blue, indicates the number of true negative predictions where the model correctly classified instances as non-return or zero. So the bottom left square, highlighted in light blue, shows the number of false negatives, where the model classified instances were returns. Notably, both the top right and bottom right squares are zero, indicating that our model did not make any true positive predictions for returns. So overall, the confusion matrix reveals insights into the model's strengths and weaknesses in accurately differentiating between return and non-return instances.
For the evaluation, the objective of these evaluations to assess the effectiveness of different statistical model techniques in answering our business question regarding how preferred payment methods vary between customers with multiple purchases and those with single purchases in e-commerce data set. We employed several statistical model techniques to analyze the dataset and derive insights into customer behavior and payment preferences. Based on the analysis we conducted, which involved performing the chi-square test of independence and feature importance analysis using logistic regression with payment method as a significant feature, we can infer how preferred payment methods can vary customers with multiple purchases and those with single purchases. Based on significant influence of payment method, the analysis revealed that payment method has a significant influence on predicting whether a customer makes a single or multiple purchases. This suggests that preferred payment methods vary considerably between these two customer groups. For the feature importance insight, the feature importance analysis highlighted the importance of payment method in the logistic regression model for predicting purchase behavior. This indicates that the choice of payment method is a critical factor in understanding and distinguishing between customers with different purchase patterns. For the visualizing variation, the feature importance visualization, such as bar chart, would show the relative importance of payment method compared to other features in predicting single or multiple purchases. A higher importance score for payment method would indicate significant variation in preferred payment methods between customers with different purchase frequency. Therefore, based on our analysis, we can conclude that preferred payment methods can notably between customers with multiple purchase and those with single purchases, with payment method playing a pivotal role in predicting and understanding this variation.
In this evaluation, we will assess how we applied association rule mining within e-commerce datasets to unravel the relationship between payment methods and customer returns. The process begins with the identification of frequent item sets, which are combinations of items frequently occurring together in transactions. Leveraging the MLextend function, we analyze transaction data, represented by the fprocess data frame, to pinpoint item sets that surpass a predetermined support threshold, such as 10% of transactions. Proceeding to the data that we graphed in order for us to have a deep analysis of how payment methods affect the returns of the products, the bar plot reveals that there is some usual pattern within the data graphs. We can clearly identify that some of the payment methods have the same rates of returns, but the small amount of difference between the returns of some particular payment methods can still affect the business applications of the e-commerce. Our findings in this bar plot reveals that there is no significant effect on the payment methods correlating to the returns of products, but it is somewhat small compared to other business-related questions. The cash payment method amounts 30% of returns. The credit card payment methods amount 37% of the total amount of returns, while PayPal payment method has a 33% of the total returns amount within the dataset.
For the evaluation of the third question, in this part, we look at the complex structure of return dates across various age groups and product categories as reflected by the bar plot depiction. Our findings shed light on the complex interaction between customer demographics and purchase patterns, offering useful insights into the elements that influence return inclination. Next. So our analysis of return rates across age groups and product categories uncovers complicated patterns that highlight the relationship between consumer demographics and purchasing behaviors. It provides useful insight for strategic decision-making in the retail sector. So we see slight differences in return rates across age groups, indicating that customers have varied preferences and habits that impact their interactions with various product categories. For example, the age 18 to 24 group has a tendency to return items in the home category, which might indicate either dissatisfaction or a mismatch with product expectation. For the 65 to 74 age group has a greater return rate for books, indicating they may have special preference or concerns with the product category. But furthermore, our classification results give actionable information by identifying the product categories with the highest return rates for each group. Notably, electronics emerged as a persistent concern across age groups, including 25 to 34, 45 to 54, and 55 to 64, signaling possible concerns with product quality, functionality, or user experience that led to higher return rates. So retailers may use classification techniques, such as the one used in our research, to build focused initiatives to reduce return rates and improve overall satisfaction with customers. So tailored marketing campaigns, product upgrades, and quality assurance methods may be adapted to meet the individual wants and preferences of various demographic segments. It will optimize product options and support long-term success in the retail industry.